2.1 Quadratic functions and models. Fill in the blank. The quadratic function is also known as the blank function. Squaring function. What about quadratic functions are blank degree second polynomial functions? Second degree. The graph of a quadratic function is a special type of blank-shaped curve called a blank. U-shaped curve called a parabola. Can you think of some real-life applications resembling this shape? The shape we're referring to is this shape or this shape. So this is when your parabola opens up. This is when your parabola opens down. So for example, if we are shooting a basketball, you'll have this trajectory, the ball will have this trajectory basically. Or bouncing a ball, right? It'll have this trajectory. So this shape occurs in real life. And that's why we studied the quadratic function probably more than we study other functions. Graph f of x equals x squared. We have x, f of x. Let's plug in some numbers for x. And this is just a review because we understand that x squared is a parabola and it's U-shaped. And we've already graphed f of x equals x squared. So this is a review. Negative 2 squared would be 4. Negative 1 squared would be 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. So we already know that we're gonna, when we plot this, that is going to be a U shape again. And we're gonna do our best to draw a nice U shape. Now, what are some characteristics of a quadratic function? Well, the general form of a quadratic, the general form, let's call this the general form. Y equals ax squared plus bx plus c, and a being our leading coefficient. Leading coefficient. Notice that a is not the same thing as x. A is the number in front of x squared here. The graph is a parabola, a U-shaped figure. The parabola will open upward or downward. And what is that based off of? Whether the A is positive, we get a smile, a positive person, right? Smiles. So we get a parabola that opens up. If our A is negative, however, then we will get a frown. A negative person frowns, right? So our parabola opens down. A parabola that opens upward contains a vertex that is a minimum point, like this one. All right, so this is a minimum point right here. That point right there is called the minimum point because it's the lowest point on the graph. Versus this point over here is our maximum point because it's the highest point on this graph. The domain of a quadratic function is all real numbers. And we know that symbol to look like what? What is the symbol for all real numbers? It's that double R. And then in interval notation, what would it be? Negative infinity to positive infinity. An axis of symmetry, also known as a line of symmetry, divides the parabola to mirror images. So yes, if we divided this parabola right here in half, that's called your axis of symmetry. So these just happen to be on the y-axis. So that line is x equals 0. And for axis of symmetry, it's a vertical line. So to represent a vertical line, you always have to put x and equals in front of some number. X equals some number. And in this section, you will learn that the axis of symmetry is x equals h, whatever h is. And we will discuss that in a few minutes. The x-intercepts are the points at which a parabola intersects the x-axis, and these points are known as zeros, roots, solutions, and solution sets. So this is saying x-intercepts can be called zeros as well. It can be called roots. It could be called solutions and solution sets. So if we use those words, we're using those terms interchangeably. Each quadratic function will have two, one, or even no intercepts at times. So let's see what they mean about all of these characteristics. On the next page, we have a quadratic function in standard form. So this is considered to be in standard form. What is standard form? Right here. So it's best to memorize this formula here. This is f of x equals a times x minus h squared plus k. What does a represent? It represents the leading coefficient. Now, the reason why we like the standard form is because the standard form sort of immediately gives us information that the general form doesn't, right? If you look at this standard form, g of x equals 2 times x plus 1 squared minus 3 right here, you already can determine the transformations, like the vertical shift, for example. We have a vertical shift down 3 units. We have a horizontal shift to the left. So we know our vertex is going to be right there, right? And we know there's going to be a parabola, and we know that it is going to be a vertical stretch because of this 2 in the front. So it's going to be a little skinnier than normal. All right. And it also can help us figure out what the intercepts are. So x-intercepts, for example, we can set this form to 0. And let's see what we get here. We can add 3. We can divide by 2. So that's x plus 1 squared equals 3 halves. Divide by 2. Well, square root both sides. Okay. Plus or minus square root of 3 halves. Then subtract 1. So x equals negative 1 plus or minus the square root of 3 over the square root of 2. And I'm going to rationalize that right quick. So that's negative 1 plus or minus the square root of 6 over 2. So if you put that in a calculator, we know we have one intercept that's negative 1 plus the square root of 6 over 2 comma 0, and the other one is negative 1 minus the square root of 6 over 2 comma 0. And so what is that really? Plus the square root of 6 divided by 2, negative 1. So that's approximately 0.2. And what is negative 1? Let's see. Minus. Okay. That's approximately negative 2.2. So on the graph, if I plot some points here, then 0.2 is somewhere here, and then negative 2.2 is somewhere over here. So you see where that is crossing the x-axis, right? But even the y-intercept, if we had to find the y-intercept, I prefer using the general form. So let's talk about the general form. How can we get this standard form into the general form? All right. How can we get the standard form into the general form? So I'm going to erase this. You can always rewind to get that. So we want to know how to convert from the standard form to the general form. Well, we'll write all this out, right? So we have 2 times x plus 1 times another x plus 1 minus 3. G of x equals 2 times x squared. So we're going to forward this out. Plus 1x plus 1x is 2x plus 1 minus 3. Then g of x equals 2x squared plus 4x plus 2 minus 3. G of x equals 2x squared plus 4x minus 1. So this is the general form. Same function, just a different form, right? So if you compare the two, see the differences. One form, the standard form, allows us to immediately know what is going on that graph because of those transformations. Vertical shift down 3 units, horizontal shift to the left 1 unit. And the general form doesn't quite give us that information. What I do like the general form for is to find out the y-intercept. Now, I do like using the general form for that. So we're going to plug in a 0 for x here. So that's 0 plus 0 minus 1. So g of 0 equals -1. So what is the y-intercept? It is 0, -1. So it's crossing, and I did a pretty good job because it is crossing right there at 0, -1. So I didn't know that, but because I uh, sketched it fairly well, it already hit that 0, -1. Now, you could always find the y-intercept from the standard form as well. So I just want to make sure you know that. So this is the standard form. You can still plug in a 0 here. You will still get the same answer, right? So that's g of 0 equals 2 times 1 squared minus 3. G of 0 equals 2 times 1, which is 2 minus 3. G of 0 equals -1. Same thing. And not too bad, but for some reason, general form is easier for me to plug in that 0, easier on my brain to calculate. But it doesn't matter. You can always use the general form to find the y-intercept as well. Now, let's go over a few items. Some important properties as they have labeled here. Important properties. Standard form of quadratic function. Again, remember to memorize this in this box right here. Right? And we're going to learn how to complete the square to do the reverse. How can we get the general form to the standard form? We're going to do something called completing the square. Right? Completing the square. Now, once in standard form, we can find out what the vertex is. So this is an example of the vertex right here. Now, what was the vertex here? The vertex here was, so again, HK. What is H? It's opposite of what you see here. Keep what you see here. So what is our vertex here? It is opposite of +1, so -1, and keep -3. So is that point right there, that point, -1, -3? Yes, it is -1, -3. The parabola opens up if a is greater than 0. So what is a here? The leading coefficient. If a is positive, that's what it's saying. A is greater than 0. Our parabola opens up. And if It opens down, that means our leading coefficient must have been negative. All right, so above our leading coefficient was 2. Therefore, that's why our parabola opened up. All right, so here we have the general form versus the standard form. So let's look at the differences. Again, f of x equals ax squared plus bx plus c. F of x equals a times x minus h squared plus k. A is the leading coefficient. The vertex is represented by hk. So again, opposite of what you see here. Opposite of what you see here. Keep what you see here. HK. All right. And then our above, our leading coefficient was 2. Our vertex was, we already discussed, -1, -3. And then our axis of symmetry, the formula is x equals h. And what is h again? H is right here. It always would be. So if you found the vertex, you automatically know the axis of symmetry because it's x equals h. Let me emphasize, for the axis of symmetry, you must put x equals in front of the number. You cannot just write the number that h represents. Okay, you have to put x equals. X equals represents a vertical line. So you must put that x equals in front of the number. That's very important. So the axis of symmetry for this function above is x equals -1. All right. So let's put the general form as a practice. The general form. So the general form, let me put g of x equals, looks like I erased it, didn't I? 2x squared, I remember, I think, plus 4x minus 1. That's what I think it was, but let's make sure. So that was 2x squared plus 4x plus 2 minus 3. Yes, so that's minus 1. So I'm going to show you now how to get that into standard form. All right, so step 1, factor out the leading coefficient from the first two terms. So here we go. We're factoring it out. We got g of x equals 2 times. So if we factored out 2 from this 2x squared here plus 4x. And we just factor out the a, not factoring like we normally factor, like the GCF. We're not factoring out the GCF, we're factoring out the a, or the leading coefficient. It will be x squared plus 2x. Okay. Step 2, we're going to do something weird. It's going to be this little formula here, b over 2 squared. And so b is going to be this number that's right, this number here. Number right here. We're going to choose that number right there, divided by 2 squared. So that's 1 squared, which is equals 1. Step 3, we are going to add and subtract that number we just found inside parentheses. Okay. All right, so we have g of x equals 2 times x squared plus 2x. Put a little space there. Um, so it's going to be now plus 1 minus 1. Step 4, recognize the perfect square trinomial. And take the unnecessary info out of parentheses. So the perfect square trinomial is right here. Notice if we factor that, we get x plus 1 times x plus 1 again. In fact, we know that from here, right? If we factor this, x plus 1 times x plus 1. So that's a perfect square trinomial getting us in this form over here like that. So what we're going to do is take out this part right here. We don't need it. But when we take it out, we have to recognize or understand or don't not forget that this is attached to, hold on, it's attached to the 2. So when we take it out, we got to multiply these two things and take it out. So that's why we are going to get now g of x equals, write the 2 here, x times x squared plus 2x plus 1. Close that up, minus 1. But on the outside, it's going to be 2 times negative 1, which is negative 2. Now, step 5, let's factor and simplify. So when I mean by factor, that g of x equals 2 times x plus 1 squared minus 3. Now, is that what we had up here? Yes, indeed. So thank God we made it. All right, so right here, this is how we ended up getting from the general form to the standard form. All right, so this is the standard form, which gives us a lot more information than just the general form, immediate information, I would say. All right, so we're going to try a couple more. All right, we said we have put g of x equals x squared minus 6x plus 2 in standard form. Okay, so I want you to keep these steps very, very close to you, in front of you, until you memorize the steps. So again, I'm not going to write the steps back over. We're just going to follow the instructions. So we have g of x equals, we're going to factor out a. What is a? A is not x. Again, let's look back at it. This is x and a is over here. That is not x, right? Let's look at it again. Over here, the a is not x. It is what's in front of the x squared. It is not the same thing as x. So it must be 1. So we're going to act like we're factoring out a 1 from the first two terms. Second step, we are going to do our b over 2 squared. So we're going to take this number that's in this spot right here, divided by 2, divided by 2. Negative 6 divided by 2 is negative 3, and square that number. We're going to get plus 9 minus 9. We're going to add and subtract that number, and then we're going to recognize the perfect square trinomial right here. Perfect square trinomial. We're going to take out this negative 9, but remember, it is associated with that 1. So 1 times negative 9 is negative 9. Always multiply that and take out that product. Now, 1 is not necessary that we write that, right? We usually don't write 1, but I wanted to emphasize it earlier because we are factoring it out. All right, so we took that negative 9 out because 1 times negative 9 is negative 9. Let's factor this. So g of x equals x. Again, this is the trick to this. The square root of x squared is x. Write down this sign right here, minus. What is the square root of 9? 3. So it will always be a perfect square trinomial, meaning that we'll get the same factor twice, meaning we can write that one binomial squared. This gives us the standard form, which gives us so much more information, right? For example, it tells us what a is. 1, it tells us if the parabola opens up or down. Does it open up or down? Up. It gives us the vertex. The vertex is HK. Again, that's opposite of what you see here and keep what you see here. So that's 3, negative 7. Because our parabola opens up, is that a minimum or maximum point? It is a minimum point. Our axis of symmetry, the formula is x equals h. X equals h. So our axis of symmetry is x equals 3. Again, do not just say 3. Always say x equals 3 just to get in the hang of putting x equals in the front. And then also we can determine what our x-intercepts are. So for the x-intercepts, I like using the standard form. I'm going to set that to 0. Add 7. So that's x minus 3 squared equals 7. Square root of both sides. X minus 3 equals plus or minus the square root of 7. Add 3. X equals 3 plus or minus the square root of 7. Now, the exact answer, the exact x-intercepts are 3 plus the square root of 7, comma 0, and 3 minus square root of 7, comma 0. Now, when you are graphing by hand, of course, you do want to know what is 3 plus square root of 7. So you can put that in your calculator. And that's approximately 5.6. Okay. And what is 3 minus the square root of 7? That's approximately 0.4. So when you graph your x-intercepts, you're going to have a point over here and a point over here. And then you have your vertex. It's 3, negative 7. That's a point. All right. The only other thing that I want you to know how to do is the y-intercept. So these are the important points. The vertex is a point I want you to know how to find. The x and y intercepts are points I want you to know how to find. All right, y-intercept, I prefer using the general form for that. So that's g of 0 equals 0 squared minus 6 times 0 plus 2. So that's g of 0 equals 2. So I'll grab crosses at 0, 2, and I'm going to attempt to draw a nice little U here. That was pretty good. All right. And of course, again, just emphasizing the axis of symmetry is the line that splits this parabola in half. This is the line x equals 3. Notice it does cross at 3 on the x-axis. All right, let's try this one. Put g of x equals x squared minus 14x plus 54 in standard form. So again, we're going to act like we are factoring out a here because 1 really doesn't affect anything. But let's go ahead and put it here. I'm going to leave a space here because now we have to do our b over 2 squared. What is that b over 2 squared? Negative 7 squared is 49. So plus 49 minus 49. This is our perfect square trinomial right here. So that means let's take out this right here, which is attached to that, right? So that's g of x equals, I'm going to drop that 1 there. So plus 54 and then minus 49. So let's go ahead and factor and simplify here. So that's something squared again. The square root of x squared, x, the square root of 49, 7, and just drop down that first sign right there. That's the easiest way to factor a perfect square trinomial. And then 54 minus 49 is 5. Now, what is A? A is 1. Does the parabola open up or down? Opens up. What is the vertex? HK. What is HK? 7, 5. Is that a minimum or maximum point? Minimum because our parabola opens up. What is the axis of symmetry? That is x equals h. X equals h. What is h? 7. Now, let's find our x-intercepts. X-intercepts, how do we do that? We set that function to 0. I like using the standard form for that. So let's subtract 5. And you begin to see we're about to run into an issue because we're about to square root both sides. And there's a negative under that square root. So no, as a result, no x-intercepts for this particular problem. Now, what about y-intercept? I like using the general form. So I'm going to plug in a 0 into the general form. 0 squared minus 14 times 0 plus 54. And our y-intercept is 0, 54. So we have a couple important points. Vertex is 75. That's going to be off our little scale over here, right? And then 0, 54, that's like way somewhere over here. So it's doing something like this, and we had to guess way off our little scale here. You can always use Desmos or GeoGebra to plug in this function so that you can see that the graph does cross the y-axis at 54 and it never crosses the x-axis. And the minimum point or the vertex here is at 7, 5.